Hello, welcome to new Cube video about internals of Cube. I'm your host Pavel Savyanko, and today I would like to start to talk a little bit about internals of the Cube file layout, how the file .cubex is actually organized. I will split this lecture on several separate lectures. First, I will talk about the wrap of the file, and then about every data type specifically. And today we talk about the general structure of .cubex file. Before we go into it, I would remind you to subscribe to the channel, comment if you have any questions, press like, of course, and let's start. So here, okay. So first of all, and the first thing what one has to know is that the .cubex in its external and general structure is nothing else than just tar file. We have chosen the tar format as a wrapper is because we need to have random file access, and tar allows to calculate position of every basically data set within a file relatively easily. It has also a relatively easy structure and allows also to store different types of files, because Cube data model consists out of different data types and of different data. We need that such a container basically. So okay, so today is .cubex file layout, and what's going on here? Okay, so the lecture today is about the file layout. So file layout, and that is the main thing what one has to basically keep in mind. cubex is equal .tar, and actually probably that is the main message of this video, and that's why it will be probably shorter than other videos. This is the that's all what we need. One can always rename .cubex into .tar and use the utility tar to split and to get every file, every data separately, and that's what we use for debug purpose, and that is how one can detect if maybe some bug in a writing library occurred, and the data corruption is occurred, and so on and so on. So okay, so today I will give you the short introduction intro into tar, and I will explain you which files do we store in this container, what for which purpose, but exact layout and exact format of these files I will then explain in the next lecture. So that is basically sequence of files plus tar headers, because the tar utility was developed originally to prepare file for storage on a tape, basically taped archive. It has nothing it is nothing else than just a sequence of file and a header which describes this file. So header, file, header, file, header, file, and that's aligned on 512 bytes, basically how the previously data storage system was organized. So okay, general layout. I will write a little bit about tar layout so that you maybe have more or less idea about it. So .tar layout. And so I will use different colors. So that's, as I said, it's nothing else than just header. Then goes file content. I will like this. It ends at some random basically size or place. That's why the tar introduces there such a feeling to align it with 512 bytes limit, and then it goes actually the next tar header and the next file, it ends somewhere, and again the feeling with zeros in up to the 512 limit, and then it goes, of course, further. Let's see, let's imagine that it goes here all the way through file, and then we get to the last file in the tar archive. It's like this here, and then it again has filling to with the zeros to 512 bytes border, and then there are two basically empty headers. So each of them are 512 bytes. So the limits are here, like here is the start 0, here is 512, here is something, here is multiple of 512 bytes, and so on. Here is again multiple of 512, here is multiple of 512, and these are multiple of 512 bytes. The exact layout of tar header you can find, of course, in every online Wikipedia article or actually explanation of tar utility. So I will just mark here header 1, header 2, and header n, and this is like file 1, file 2, file n, and this is like a legend data. This would be then tar header, and this is padding basically. On 512 bytes. So that is the basically the structure of every tar archive. You get header, there is description, there is a name of the file is stored, there is a owner, creation time, size, ID of group, of user ID, and. So there are plenty of data stored, and also of size. Yeah, so let's make some summary short here about important properties of tar headers, which are relevant for cube. Tar header. Yeah, and that is, first of all, 512 bytes. Every tar header is 512 bytes. Then the file, and then it's padding up to 512 bytes limit, and then again and again. This is what we keep in mind. We create a proper tar header with all data filled correctly in order so that the tar utility can read it and work with it. But for cube library, actually, we need only name and we need the size of the file. So the complete and correct tar header, but cube, I would say cube, not cubeLib, just cube as such, cubeW, cube library needs or uses, I would say uses only name and size. These fields. Everything else is ignored by the library itself. That's why the situation can occur that the tar header is corrupted. The library cubeLib can open this cube file and work with the data, but tar utility strikes. Okay. About the tar layout, tar header layout. Tar header layout you can find in every online resource. See online documentation. Also worth to notice, there is a limitation of standard tar utility, is that if the size of or opposite, the standard default format of tar header doesn't allow to encode or to store files with a size bigger than 8 gigabytes. That's basically the width of the field for size doesn't permit number which is larger than 8 gigabytes. There is a solution for that, so-called POSIX extension, and we do support it. So in the case if Cube library creates or has to store data larger than 8 gigabytes, it will actually produce POSIX extension of tar utility. Tar utility should understand it, but in a case if you want to debug into it, you should keep it in mind. So if file size is larger than 8 gigabytes, then we basically create POSIX extension of tar header or tar format, basically. Okay. So yeah. Okay. So now I will explain, of course, what kind of files, what kind of data do we store within this tar layout, and for which role do they play. Okay, so the files. Which files are stored? Files in CubeX. So first of all, if you expand every CubeX file, you will find there such a file with the name anchor XML. That is the file where we store description of the structure of cube file, of cube data model, description of metrics, description of call tree, description of system tree, topologies, and. This is so basically just of cube object, basically. Description of dimensions like metric tree, metric call tree, system tree, system. There can be also taskings, for example, tasks. The topologies, attributes, and. The syntax of this Anchor XML file I will explain again in another videos of this series about the layout of CubeX file. Okay, then there are basically sequence of files with a number, and then either it is index or data. So there are pairs of files. One is, for example, 0.index, 0.data, 1.index, 1.data. This is this couple, this pair describes the data for every metric, and it's metric data. This number, this 0 hash, is a metric ID. And it's exactly this metric ID which is stored or declared in Anchor XML. The 0.index file describes the index with which we can address the actual bytes within this dataset. So .index, and this index describes index. I will explain now. And data is actually data rows. Layout of this data file I will also explain in a separate video just after I will demonstrate what's about Anchor XML. So the looking ahead, we support or we use two formats of index or two representation of data, dense and sparse. In the case of dense, the index basically is very short, it's just dense. And in the case of sparse, we have to address actual stored rows, and there is the actual index of these stored presented rows is listed. Okay, so that is let's mark it. Here Anchor, and here is this. Then another file which is stored in CubeX since I think Scorpy 7.0, something in there, or 8, is remapping .spec. So if you experience with performance measurement using Scorpy and using Scalasca, maybe you have read a guide, maybe you have been visiting tutorials and workshop, you know, at least after that the biggest value the measurements of Scalasca and Scorpy have after the so-called remapping. When one transfers raw measured data and makes hierarchy of time and others metrics. This remapping step requires specification. There is a specification for remapping for data produced by Scorpy, that is profile.x, and one gets out of it summary.cubex, and raw data from Scalasca trace tools, that is scout.cubex. It has also own remapping specification. Then one gets so-called trace cubex. So this remapping specification, it's very similar but still different. It's for Scorpy and Scalasca, and that is this file. So that one can take profile cubex as a standalone file and apply cube remapping tool on it. It will take the remapping specification for this file because the file was produced by specific version of Scorpy, and this specific version of Scorpy has a definition for metrics and its own definition of this remapping file. With the development of Scorpy, for example, one might introduce some either specific regions or specific new raw measured data, and one defines also suitable remapping files for it, so that one can have a measurement and this remapping specification always matching, and not to run into situation that one takes newest measurement but old remapping specification and does it, and then wonders where is my data, or opposite. So this is this file, and the last, probably but not least, there can be, so I will write here, oops, I will write here, that is score p slash Scalasca remapping specification. Okay, and the last but not least, basically very generally, name. There can be any file. It can be some maybe statistics, some configuration file, whatever. These such files, they are treated like simple general files. One has a special call. Let's say I will write it like this: get misc, and here is usually name of the file. And one gets access to this data within a Cube library. So this can be any possible file, whether it's statistic, as I told, some maybe some counters or something like that, and one has access to it from the library within. And actually, whole magic is done. That's all what one has to need about has to know about the layout of cube file. That is the tar file, and it has some specific set of files inside, so that one should not wonder what are those files after the extraction in a directory. Okay, that's all. I remind you, subscribe, write us comments, and press a like, and see you next time.